great pleasure and true honor to open this project entitled Religion, Ideology and Pro-Sociality. Do you have any problem with hearing me? Is okay? No, you hear me? Okay, thank you. And it is very important to emphasize at the beginning that the project is funded by Polish National Center for Science and in commitment with Norway under the mechanism called Norwegian Financial Mechanism for Scientists. And we know that this program covers many activities, many scientific activities in European countries. The project will be implemented in collaboration between University of Białystok with Professor Talmont-Kamiński as a main coordinator, and in Norway with the research center with Professor Ron Schultz as the main also as the coordinator. The main topic of the project is to elaborate computer model based on different aspects of scholarizing societies. And based on this model, we will be able to predict different behaviors at individual levels and at society levels. More details about the project will be provided by Professor Talmont-Kamiński. And I would like to say a little bit words to those who do not know anything about University of Białystok. Our university was established 22 years ago. And so it is pretty young organization. Nevertheless, the history of our university is much, much longer, as for many decades we had existed as a branch of Warsaw University. And telling the truth, we took from our mother school traditions, scheme of organizations, and what is the most important, we also took a huge involvement in science, a strong passion for work. Although our university is pretty young, we belong to the quickest developing universities in Poland. And at the moment, we are the biggest university in northeastern Poland. In our structure, there are 9 faculties and 6 institutes. And what is worthy to emphasize, we are the only one university in Poland in a branch abroad, which is located in Vilnius in Lithuania. Although we are young, we are strongly focused on both science and student education at the highest levels. And also our university is widely open for different forms of collaborations, also including project implemented with scientists from abroad. Hopefully, thanks to this project, during this project implementation, we will convince Professor Schulz and his team that University of Białystok and people working here are reliable and responsible partners. And I look forward into developing a long-term collaboration between NORCE and our university, not only in sociology, but also in other scientific fields. Ending, I wish you successful implementation of the project. I wish you intriguing results, which will be published only in high-rank journals. And at the end of the day, hopefully we'll know much more about mechanisms which direct secularization in societies, and also we will provide model which will be helpful in prediction human behavior. I expect also that thanks to this project, Białystok very soon will become a world-recognized center where computer modeling is successfully applied in order to understand social phenomena. Thank you very much. Thanks.
Thank you very much, Professor. Laurent, would you please be so kind and say a few words from yourself? Laurent Schultz, the head of the our partner in Norway.
Yes, thank you, Konrad, and thank you to the Vice Rector for those very kind and encouraging words. We too really look forward to the long-term collaboration, not just these 3 years, but beyond. And Konrad, I know, is going to say a bit about what's going to make that possible. Just briefly about the Center for Modeling Social Systems is a part of NORCE, the NORCE Research Institute, which is actually even younger than Białystok, only 2 years old. Although it's the combination of many centers from all over Norway, in Oslo and Bergen, Stavanger, Tromsø, and here in Kristiansand, that have existed also for many decades. But they were all combined 2 years ago to make a new center. We're in the social science group, and there are about 900 employees throughout Norway in NORCE, and we're really enjoying building the center within this context. The project with Professor Talmont-Kamiński is the largest one we have right now, and we're super enjoying it so far. Looking forward to next steps, and it's really a pleasure to be part of this launch.
Thank you very much, Laurent. As Laurent said, I'm going to say a few more details about what the project is about. What I'll do now is I'll try and share my screen. Laurent, if you could just nod that you can see my screen right now. Okay, lovely. Right, ladies and gentlemen, the project, just first of all, to start off with just a few details about the project, and then I'll say a little bit more about the particular models that we are thinking of putting together during these 3 years. So, as has been said, the project is run as a partnership between the Center for Modeling Social Systems and the Society and Cognition Unit. The funds are coming from the Norwegian funds. In the amount of money we have for the project is about 5.5 million Polish zloty. The project is overseen by the Polish National Science Center, and it will run for 3 years, perhaps a little bit longer, depending on how COVID interferes with our schedule. The main aim of the project is to develop a number of computational models of social phenomena, in particular social phenomena connected to secularization. What exactly that means we will see later with Ivan's presentation. The aim of the project is to build a long-term collaboration looking at computational models of social phenomena between Białystok and Kristiansand. Importantly, and this will have the aim also of developing in Białystok a permanent center, which will be focusing on this type of research, where of course this type of research, because it will allow us to make predictions about social phenomena that already previous studies have shown are highly accurate, will be, of course, highly socially significant. Now, the team. The team of people who are involved in the project at this point, of course, includes people from Kristiansand and people in Białystok. From Kristiansand, we have Laurent, who of course has already talked, and we also have Ivan Puga Gonzalez, who will be giving the presentation later on this morning. In Białystok, we have myself. We have also Alexandra Dudek, who is the administrative manager of the project. We have 2 postdocs, Nuno Magesi from Portugal and Tommy Coleman from the US. And we also have Łukasz Kiszkiel, who is a quantitative sociologist, and he's helping us with a lot of the analysis of the data. and Paweł Łowicki, who is a cognitive psychologist and helping us design some of the experiments that we'll be talking about later in the week. Finally, we have Claudia Komar, who is a doctoral student also involved in the project. I almost forgot. There's one more person that's helping us. No, not Chris Hemsworth, of course, but Thor. Thor is the name of the computer system that will be used to run the computer simulations upon. As such, it will be an absolutely essential piece of hardware, and it will be specifically designed to allow us to carry out models of social science phenomena. For those who have some idea about these kinds of details, technical details, it's going to have 128 or more CPU cores, and it'll have more than 2 terabytes of memory. It'll be located in Białystok at the University Computational Center, and vitally, because it is such an essential piece of hardware, it will be available for other projects that will be attempting to develop computer models of social phenomena. Now, what models are we trying to develop during this project? Well, as we'll be talking about them all week, it's probably good to introduce them. There will be 4. And there will be the pro-social equilibrium model, the epistemic vigilance model, the fuzzy fidelity model, and finally the error management model. So allow me to quickly introduce them right now. First of all, the pro-social equilibrium model. Here the idea is that what you have is, with the normal functioning in traditional societies of religion, you have religion and other aspects of the societies often functioning at equilibrium. For any society to function, a certain amount of pro-social behavior is required from its members. Now, as the amount of pro-social behavior in a society grows, roughly speaking, we can talk about the levels of anxiety falling. The reason for this, of course, being that people, thanks to the pro-social behavior, are relatively secure and their lives are relatively comfortable and the future is relatively guaranteed. Now, on the other hand, we know that growing anxiety seems to be closely connected to growing religiosity. And also, it seems to be the case that increases in religiosity lead to growing pro-social behavior. So what we have here is an equilibrium. If religiosity falls too low in a traditional society, pro-sociality will fall and anxiety will rise, leading to a rise in religiosity and evening out things. The important phenomenon connected to secularization that we'll be looking at is the idea that with secular institutions, you have a high level of pro-social behavior, which is independent of religiosity, so that anxiety falls and religiosity falls further without an effect on pro-sociality. This provides a very simple model for why you get secularization in many modern societies, and we'll be testing to see to what degree the predictions of this model hold. The second model is the epistemic vigilance model. Here the main idea is that most human learning is what's known as social learning, in that we learn from others. In particular, we learn from what others tell us. Now, of course, when we are learning from what others tell us, we have to engage in a little bit of vigilance, insofar as we have to make sure that what they're telling us is worth acting upon. Now, we can do this based on 2 kinds of information. Firstly, we can look at what they are telling us, the content vigilance. If what they're telling us sounds reasonable, if it fits with what we already know, if it's internally consistent, these are all good signals for it being a reasonable thing to act upon. However, we can also, and we do in fact, think about who is telling us the information, why they're telling us this information. If the person who's telling us this is someone who wishes us well, if there's someone who is competent in the particular area, again, these are good reasons for trusting that person. Now, both these kinds of vigilance are used in common sense reasoning. The idea that's relevant to religion is that in the case of scientific institutions and religious institutions, you have a particular focus being placed upon different kinds of vigilance. In particular, the idea is that scientific institutions lead to a focus on content vigilance, whereas religious institutions focus on source vigilance. Now, the reason for this, the pro-social function of religion that we talked about with the previous model is not connected to the accuracy of those religious beliefs that cause that pro-social behavior. In other words, what you have here is a function which is monolithic. It is not connected to the truth. Now, this is important because if you focus simply on the source rather than on the content, you can in the end have a tradition of beliefs and practices, which is also monolithic. So this is the second model that we will be testing. The third model is the fuzzy fidelity model. And in the case of the fuzzy fidelity model, the basis of it is in an analysis of statistical data from a series of European societies. This analysis, carried out by David Voas, appears to suggest that the process of secularization is, roughly speaking, a 200-year process, which, and this is very important, appears to be quite similar in different societies. This is a very surprising finding and a very important finding. Another element of that is that it appears that there is an intermediate stage in that process where, if you look at the blue line, that's the number of religious people in a society, and the number of secular people in a society is the gray line. During the intermediate stage, you have the growth of what David Voas calls fuzzy fidelity. These are people who are not secular and yet not traditionally religious insofar as they do not attend church. Their beliefs tend to be quite idiosyncratic. Their practices also tend to be quite idiosyncratic. What's important in the case of Poland and Norway is that both these countries appear to fit on this diagram, but in very different places. Poland is somewhere over here at around about the 80-year mark, where you can see a very rapid descent in the number of religious people in the society. And this is indeed what statistical data seems to be showing in Poland, that Poland is currently secularizing at a very rapid pace. At the same time, Norway has gone a lot further in this process and appears to be somewhere along here. We will be testing to see what kind of social variables could explain why it is that Norway has gone so much further in this process than Poland, for example. The final model that we'll be developing, we're calling the area management model. And the idea here is that when people are interacting with their environment, they can make two different kinds of errors with regards to what kind of influence they have on the environment. For the false positives, these are the situations where people think that they have an influence on their environment. And for the false negatives, those are the situations where they do not think so, but are wrong. So, of course, an example of a false positive for the false negative, you might engage in all sorts of behavior. You don't think it influences anything, it changes anything, but in fact, for example, it might have a long-term effect that you don't realize, not recognize. Now, these two different kinds of situations, these two different kinds of mistakes have very different relative costs in general. If we think we can influence a situation, but we cannot, we might engage in some sort of behavior which is not effective, but it usually will not be all that costly. However, if we think we are incapable of affecting a situation, and we are capable of affecting a situation, we are potentially missing out on an opportunity which could be very costly to do. Now, this means that there will be a tendency to try and avoid the false negative situations at the cost of false positive situations. In other words, there will be a tendency for people to think that they have causal control over situations where they do not. Now, this is something that we have been testing for a while now in Białystok using the pseudo game that you can see the screen of at the bottom. Here, people are asked to move the cursor, which is the round circle, on the matrix, move it to the bottom right corner, using the buttons on the right-hand side. As you can see, there's a number of buttons. Essentially, the ones pointing up, move the cursor up, right, to the right, down, to the left. As you can imagine, these buttons are not explained. Well, none of these buttons are explained. And people engage in pressing all of these buttons, thinking that which buttons they press and in which order determines whether they get a point when they get to the bottom right corner. They don't. It is completely random. However, the patterns of behavior they engage in show that, in fact, using such very simple resources, it is possible to get people to engage in what's known as ritualized behavior, which is very much connected to that illusory causal control I have just mentioned. Now, the ritualized behavior has a tendency to increase when people are anxious, when they feel that there's a threat present, which of course is exactly the kind of thing that we've been talking about previously with regards to the pro-social equilibrium model. And what's also important, there is potential in this situation to develop a supernatural interpretation for why there appears to be causal control, where in fact there is none, and there is no natural explanation why there would be one. This opens the way to explaining, using this model, why people develop traditions of belief and ritual. And these are the four models that we'll be looking at. Before I finish, there are three people I have to thank above anybody else, because this week and over the next 3 years, a bunch of us involved in the project are going to have a lot of fun doing what we love to do research. But 3 people above others have made that possible. First one, I have already shown you a picture of. That's Alexandra Dudek, who is the administrative manager for the project, but also of great value that has made it possible to carry out this research has been, of course, the Vice Rector, Izabela Święcicka, who spoke to us earlier, and also of enormous assistance, who has helped me every week since April, when we found out that we would have these funds, is the head of the Sociology Institute, Professor Małgorzata Bieńkowska. I know Professor is watching us right now, and Małgorzata, thank you very much for all your help. Now, this is all that I have to show you for now. What we have arranged is for people to be able to ask questions by typing them in on the computer, so to try and answer any questions that arise from that. Alexandra, if you could help us with that.
All attendees have the possibility to ask questions within Q&A feature. So please feel free to write questions to our investigators.
I think you were so clear, Konrad. No need for questions.
While we're waiting for people to type in questions, perhaps Professor Święcicka, perhaps you have some questions for us.
No, thank you. Not at the moment. Many thanks.
All right.
Well, oh, there we go. I think we have a question.
Right, we have a question from David Voas. Will all of the sub-projects proceed simultaneously in parallel? Laurent, you want to take this one, perhaps?
Sure. No, they won't. We have them sort of stepped in a stepped fashion. The fuzzy fidelity model is the one that we're focusing most of our attention on these first few months, and we've already made good progress on that one, as everyone will hear on Tuesday and Wednesday. Then we've also begun the pro-sociality model. This afternoon, we'll be talking about that one in more detail. Basically, Ivan Puga Gonzalez, who will speak next, is the primary computer programmer for those two models. And we'll describe as we go along who the subject matter experts are. Then there in Poland, Nuno Magesi will be the primary computer programmer for the second two models, which we're in each case, it's rather complicated. We either have surveys or the kind of experimental the experiments that Konrad was discussing to get us new data that will feed into the models. So some of those surveys will take longer, but others, especially the fuzzy fidelity model, we've been able to go ahead and get started right away.
Okay. Right. We have a second question from Witold Drugnicki. What are the connections between models? Could you draw a scheme for that? I think I probably should take that question myself because a lot of the connections between the models are based on a theoretical account that I've been developing myself. Back in 2014, I published a book with Routledge called Religion as Magical Ideology. And insofar as the models are based on my work, that work is in that book. Of course, at the same time, they're based on work of a number of other researchers. That's always the case with any scientific research. But what are the connections between them? I think, the most fundamental of the models is the fuzzy fidelity model, which of course is based on David Vars's work on fuzzy fidelity. This tells us how secularization has looked in Europe. This tells us a number of very important things, such as it has proceeded very similarly in a number of European societies. It tells us that it has appeared to be a cohort-based phenomenon, in that people who are born later are more secularized than those who are born earlier, and the age group they are born into does not seem to overall change their level of secularization over their lifetimes. That limits the possibilities as to what could be causing secularization in fairly strong ways. The prosocial equilibrium model is one way to try and explain the mechanisms behind that. If you notice there, the idea is that in traditional societies, without strong secular institutions, you have an equilibrium between prosociality, anxiety, and religiosity. The explanation given for secularization, according to that model, is the growth of secular institutions, ensuring prosociality and thereby providing security in a society long-term without the need of religiosity. That suggests that secularization starts at the point where those institutions are strong enough to maintain that prosociality, and that in essence, what happens at that point is that religiosity goes into free fall. If that's the case, you would expect the process to look very similar in different societies where it has begun, which is exactly what you see with David Vars's picture. Now, the other two models, with the epistemic vigilance, that tries to explain why there would be a link between anxiety and religiosity. It tries to develop the mechanisms there. So that can be fitted into the prosocial equilibrium picture that we've just talked about. Finally, the error management model that also is connected because, well, first of all, it explains why religion could focus on source vigilance, because that prosocial function isn't connected to the truth of the claims that it's making. So it doesn't have to necessarily worry about content vigilance. And secondly, no, actually, I think that's actually the basic answer there. So that's how I'd answer that. I'm sure there are still plenty of question marks to be raised, but those are the basic connections between the models. Right. Could you tell us more about the IT equipment systems you will use? Laurent, would you like to take that question, or perhaps we should ask Ivan to answer that one?
That's a good idea. Ivan, are you there?
Sure, I'm here. So the idea here, I'm sorry, I'm gonna put on my video. Okay, so the idea here is to build some kind of a supercomputer that can handle basically the main problem that we have here is the amount of memory that it's needed to run several simulations at the same time. So the types of models that we envision will be quite complicated, will consist perhaps of thousands or even tens of thousands of individuals, and each individual will have several different variables. And each individual will have its own functions. It will have the capacity to take their own behavioral decisions, who wants to interact with, etc., etc. And this requires a huge amount of memory for each of these individuals. And then if you can imagine that these are going to be thousands, then we need a machine that can handle this at all times. So then we envision a machine that, as Konrad says, it has at least 2 terabytes of memory, so that when the simulation is run, and if we're running simulations in parallel, so that's also why we need so many cores. So in the software that we use, that it's called AnyLogic, so we are able to run simulations in parallel, and then each of these cores will run a simulation. But of course, these cores will need access to all this huge amount of memory. So that's why we need such a huge amount of RAM memory in these computers. So that's basically the reason.
Okay, thank you very much, Ivan. Another question from Witold Rudnicki. And Laurent, perhaps if you can take this, I'll just read out the question. It seems on surface that secularization processes in certain countries, Spain and Ireland, for example, were much more rapid than you have shown, from complete control of the society by the Catholic Church in the 1960s till nearly full secularization by 2020.
Yes, very great question, Professor Rudnicki. One of the, as we'll talk about more tomorrow and Wednesday, the analysis that David Vos made is based on the data from the European Social Survey, and it shows across different countries how those beautiful curves that Konrad showed earlier tend to flow. But when you have cases like Spain and Ireland, where things seem to go more quickly, or other cases where it seems to be going more slowly, then you need a different kind of methodology, one that can get underneath the hood, so to speak, to get at the mechanisms that are driving the process for all 3 types of people, religious, fuzzies, and secular. And you also need to be able to vary the parameters, the environmental factors that might be driving those mechanisms to go more quickly. So as we'll discuss when we come back to that model, there is lots of evidence that suggests macro level factors like existential security or availability of education or freedom of speech, that those tend to make secularization seem to move more quickly. So the computer models that we'll be developing will first replicate the curves that Professor Vos has already shown, but then also test the mechanisms that are driving those up and down and explore other sorts of scenarios to get at exactly the kind of question that you're asking.
If I can perhaps expand upon that, I think part of the issue with both Spain and Ireland, and actually if you look at it, Poland right now, is that you have 2 issues. One of that is the level of religiosity of the population. And that's the data that David Vos is looking at and that we're looking at in the fuzzy fidelity model. The other issue here, which is very much connected, is the issue of how much social control the church has in those societies. Now, of course, religiosity in a society and the amount of power that the church has in a society are going to be connected, but they're not going to be moving in lockstep. So I think in the case of Spain and Ireland, the phenomenon that you saw was that for historical reasons, the Catholic Church had a lot more power than was perhaps in line with the level of secularization of the people in that society. So that when you did get a social change in terms of the position of the church in that society, that change could be very, very rapid. Yeah. Other questions, please. Well, there don't appear to be any more questions for now. So perhaps we can move to Ivan's presentation. Ivan's going to present the basic ideas behind modeling, and will also expand upon what I've said about different models that we will be developing. Presentation, there will be a very long session for everyone to ask all the questions that I'm sure they will have. So, Ivan, it's over to you now.
All right. So can you see my screen there? Do you see the main?
We can see the screen, and we can see also notes and next slide. So you want to change the way in which it's presenting, I think.
Okay. Okay, let me stop share and share screen again.
We can see presenter view rather than the normal way in which things are shown.
So what about now?
Looks good.
So does it look now the main screen without the the outline and the notes and all that stuff?
Yep, looks good.
All right then. So as you probably already know, I'm Ivan Puga Gonzalez, and I'm a researcher at CIMS, at the Center for Modeling Social Systems in NORCE in Kristiansand. And today I would like to talk a little bit about what social modeling is, and then I will touch a little bit into the different projects of the Religion, Ideology, and Pro-Sociality project. Okay. Let me see. Okay. All right. So this is the outline of my presentation. So I would like to start talking a little bit about human complex systems and social phenomena. Then I will touch into the complex social phenomena about theories and models. And then I will start talking about mathematical and computational models. Then I will zoom more into the types of computational models, and I will be specifically talking about two different kinds of computational models. One is the system dynamic models, and the other are the agent-based models. And then I will zoom now into the agent-based models, into the what, how, and why agent-based models are very suitable to look at problems related or social phenomena related to the social sciences. And then I will end up with an overview of the RIP project. All right. So if I ask you guys, or if I tell you guys that humans' social systems are complex, I'm pretty sure none of you will disagree, right? But if then I ask you, okay, now tell me what's your definition of a complex system, then probably there's going to be a lot of definitions. And probably nobody really agrees on what a complex system is. And this is true from most of researchers out there. So everybody has kind of its own definition of what a complex system actually is. However, among all these definitions, we do have some specific characteristics that we can tell about a complex system. And one of them is that it actually has many interdependent components which are connected somehow, and they are interacting in nonlinear ways. So one example of the US economy, for instance, is the product of individuals. So you have individuals or millions of people, if you want to call it like that, which belong to hundreds of thousands of firms or government agencies. Now, all these are interrelated. And not just that, but there are some external factors that can actually interfere with this. So for instance, things as banal as you may call, like the weather or the interest rates in China. All these factors may affect how this complex system behaves. So then another important characteristics of these complex systems is that some little tiny disturbances in one part of the systems individual or groups of individuals living for a long time. I mean, now, whenever you have a group of individuals together, of course, you will have a lot. And these interactions may occur in different contexts. So they may compete for resources or may just be forming bonds, affiliating among each other. And this happens during long periods of time, as I just said. It can occur during their whole lifespans. And this is actually what in the biological science will be defined as a complex social system. So from this definition, then you may think, of course, then human societies falls within these definitions. So what are human social systems? So human social systems, as I just explained, is these interactions among hundreds or thousands of individuals now that actually span during different scales. So it can happen during long stretches of time, going from evolutionary to historical times. It can happen at different spatial scales. So it can go from the molecular to the whole world when you think about, for instance, interactions between countries. And the organizational scales, it's really big as well. So it can go from the physiological mechanisms leading to a behavior in an individual to the cultural factors that may also drive the behaviors of these individuals. Now, one of the aims of the social sciences, of course, is describe the behaviors of such systems in a way that is meaningful for explanation and prediction. Excuse me. So if you look at the social, behavioral and cognitive sciences, then you will realize that there's a lot of theories. But these theories is what I will call informal theories, because they are descriptive explanation on how things work. So what are the drivers of behavior? What are the drivers of how things interact, how they are connected, how they are interacting? And these inform because they somehow allow us to interpret the phenomena that we are seeing in the world. However, there is a disadvantage here. And the disadvantage is that they are not completely explicit on what they mean. So there are some words and phrases that can be ambiguous. For instance, they can use different categories. So what a category actually means, or identity. So an individual can have an identity or can learn. But this is a bit ambiguous. So it can mean different things to different researchers. So there is a need for be crystal clear in the explanation in order to unbalance these theories. So what may be the solution? The solution will be when you formalize this theory into a model. And then you can do this into different types of models. Those that are called mathematical models, or more recently, what is called computational models. So what are these formal models? So formal models are basically a simplification of a complex social phenomenon. And this simplification is not bad. It's actually helpful to ignore many of the details that maybe are not so relevant for a specific social phenomenon. And once you get a formal model, then you have a way in which you can test and extend this theory. And as I just said, then you have two different types of models. One are the mathematical ones, and the other are the computational ones. So what are the mathematical models? So mathematical models are just equations. Equations specify key relationships between the parts that compose the system. Now, one of the things with the mathematical models is that they tend to cluster individuals or components in aggregates. So they are not so detailed. You can call it like that. Now, the exploration, because of this reason, the exploration is generally easy. Let's put it like that, because there are not so many parameters. And then you can make a huge exploration of the whole parameters space in a mathematical model. So here I put an example, for instance, of what this looks like. And I'm not going to go into the details of what these equations actually mean. This is just for explanatory purposes. So what you have here is an equation on how individuals may get their opinions whenever they are interacting with some others. Now, from these equations, you can derive exact conditions under which particular outcomes will or will not occur. And then you get something what in mathematics is called theorems, which actually tells you when something or under what conditions something holds true. Perhaps an easier explanation of this mathematics everywhere in demography. And they use census data, and they cluster individuals basically in 5-year age groups. And then they use different equations, which actually describe the fertility. For instance, how many children will a woman have during reproductive age? What is the life expectancy of the individuals according to its age? Or how many individuals will come or will go out of the country during specific times? And then you get an equation that looks something more or less like this, in which the population that is projected in the future depends on the present population minus the number of deaths during that time period, plus the number of births during that time period, plus the net migration. And then you get some graphs like this. So then you get graphs, or you have different projections depending on the types of parameters you put in. So for instance, if you assume some high fertility, high life expectancy, or high net migration. So this is basically what a mathematical model will look like. Now, if you think about social phenomena, then you would think, well, these mathematical models are actually a bit limited. Why? Because when they cluster objects into aggregates, then you lose variation, you lose heterogeneity. So for instance, they are unable to explore spatial networks, spatial models or network structures within a population. So they also ignore individual differences. So for instance, you may think about different traits that may affect the behaviors of individuals, and these models actually ignore that. And the other one is that there is a high bar entry, because these models are not really easy to analyze. Doing an analytical analysis of mathematical models is actually quite difficult, depending on how hard the mathematics behind the models is. So you really need to have advanced mathematics. So when you have that additional complexity is what you need, and the analytical tractability is actually not possible, then the computational models actually provide a better alternative. So what are the computer models, just as the mathematical models, they also attempt to reproduce a behavior of a system. And these computer models have been used now for the last almost 50 years, I would say, in different research fields, such as physics, chemistry, and even biology. But it's not until the last 30 years or 20 years that this use of computational models has kind of exploded in different social sciences, so just in economics, in psychology. And nowadays, there is a new field, which is called which is using computer models to study social phenomena. And here I'm going to focus on two different types of models. There are, depending on the how you want to categorize the models, you can actually have many different kinds. But here I'm just going to focus on two of them that are relevant for the social simulation. One is the system dynamic models, and the other one is the agent-based models. Now, what is a system dynamic models? So the system dynamic models follows a top-down approach. It means that similar to the mathematical models, it can. So you have components that represent people, that represent capitals, that represent products, etc. So here I put a little diagram or a little sketch of how a system dynamic model will actually look like. And this is a system dynamic model on the adoption of new technologies. And here you can see the different components. For instance, you have the total population that can be divided into potential customers. And here you have an equation for the adoption rate of this new technology, and then you have the customers, right? Now, the adoption rate may depend on different equations. Some of them, for instance, may represent the adoption from advertising, or some of them may represent the adoption from word of mouth. And on top of this, then you have some other external factors which may affect all of these components. So each of these things here would be a kind of a mathematical equation or a differential equation. So, and as you can see here, all these components are somehow interconnected. Now, how simulation is achieved? So then you kind of divide the simulation in different time steps. And at each time step, each of these variables is updated according to how these things are connected in the system. So this is basically how a system dynamic model works. Now, agent-based models are a bit different. Instead of that approach, so in an agent-based model, what you are doing is modeling interacting agents. And these agents are usually individuals, persons, but they can be anything with an agency. So for instance, it can be institutions, it can be countries, it can be companies, etc. Now, you create now a model in which you have individuals or agents, and these agents behave according to some specific behavioral rules, and they socially interact. And from these social interactions, then you get complex patterns that emerge at the group level. So this is what it's called understanding by building. Now, one of the advantages of this is that now you are free or flexible in how much you can put actually into your system, right? So then you may have some individual variation. So you can put attributes that may be important for your individuals. So then you may have sex, for instance, you may have age, you may have social status, you may have personality. So here, this is a representation of a caricature of an agent-based model. So here you will have your target system, for instance, and then you will have individuals in some sort of environment, which will be represented in the agent-based model in some specific type of world. So individuals may be in different specific locations, and each individual will be represented as an agent in the model. And these individuals will be connected, will be interact. Some of them will be isolated. Some of them will be separated by some physical limitation, right? Now, all of these individuals will behave according to some specific behavioral rules. And these rules may be based on empirical research, but sometimes they don't. Sometimes you have to make assumptions. But then one of the things here is that agents are, they don't have complete information about the system. So the way they behaved depends on who they are or what they are seeing or what they are experiencing. Now, another thing here is that there is a lot of feedback going on. So individuals interact with each other, and they, because of these interactions, they may modify their behavior, but individuals also may interact with their environment, and they can modify their environment, and by modifying their environment, they may also modify their behavior. So there's a lot of interconnection going on here and a lot of feedback. Now, these models can be especially explicit or not. So individuals may be embedded in social networks, in different types of networks. It can be family networks, it can be neighborhood networks, job networks, etc. They can have an explicit environments in which they can exploit resources or not. So, as you can see here, we can, with the agent-based model, now we can create agents that look psychologically realistic, I would say. So these agents are basically so they can have sex, they can have education, they can have self-identity, they can have any kind of attribute you think is necessary in your model. They are goal-directed. So these individuals may pursue an education, they pursue to find a job, they pursue to get married. It depends on what your model is about, but they may be goal-directed. Now, they also sense their surroundings. So they can also sense the norms. They can have some kind of social pressure depending on who they are connected with. They can perceive policies if you implement policies into your models. And depending on what they sense, they can actually react to this stimuli. So this stimuli may trigger different behaviors. They can move in the space. So if they don't like where they are located, they may move to some other place. And they interact with others and their environment. So they exchange information, they can actually cooperate or compete with some others, they can form bonds, and they can form social networks. So to summarize a little bit about the agent-based models. So agent-based models enable researchers to generate or grow the phenomenon. Right? And this is unique because by doing so, we as researchers can actually dig into what are the causal relationships among the different scales of social organization. So what is causing what in these models? And this goes just from the micro units, going to the meso level, so the interactions between the different agents, to the macro levels, which are the properties of the group. So you can really understand all these causal relationships going from the lowest level to the highest level in these types of models. Excuse me. So why use agent-based models? So I will touch now into these 4 different points. Some of them I have already mentioned of them. I just want to emphasize them here. So the first one is when mathematical models are not enough, when you can use these models because there is a great number of threats. The second point, it will be when random events may be important. A third one is when hypotheses are actually there. And the last one, and I believe the most important one, is to gain a better understanding of a system and then create a better theory. So when do mathematical models become interactive? And as I just mentioned here, and I hope now you agree with me, this happens when you have in a social system multiple interacting elements. And these multiple interacting elements are actually hard to predict. This also happens when social interactions rely on internal processes and they vary greatly. For instance, you may think of agents social interacting based on their experience or based on their knowledge or based on what they learn or doing some kind of uncertainty or a combination of all these things. When there is no linear processes and complex dynamics going on into these systems. So all these calls for we have a need to integrate this knowledge and these processes into a whole. What we want is to understand how interactions at the individual levels may produce patterns at the societal level. So then this makes mathematical models actually not so good, because it will be sometimes impossible to make an analytical solution of a complex system. And that's why it is better sometimes to use ABMs. Now, another point is when the random events may be very important. And this is mostly important whenever you are sometimes maybe. So individuals make errors whenever they are measuring something or estimating an outcome. And this is a source of stochasticity. Or they may be biased in their decision making. So for instance, they may be ignorant about something, or they may be biased because they have some experience previously, or because they are learning. So all these may bias how they are making their decisions. Now, there may be some stochasticity going on how they interact, right? So are they interacting based on proximity, who is closer to you? Or they are just interacting with someone at random? Or are they based on some kind of a specific rule? Stochasticity can for instance, natural disasters, right? Although we know that on average, natural disasters happen in a certain amount every year, that doesn't mean that every year is that amount actually happening. It may be that sometimes there's no natural disaster occurring in 1 year, or it can be that in 1 year, 4 or 5 natural disasters occur in a row. So it is actually like playing dice, right? It can be also chance events, for instance, deaths of individuals, and these deaths of individuals may occur at any given age, and these may have some kind of repercussion on the way individuals behave, right? So whenever you have that these random events are actually essential, and these may have consequences on how individuals behave, then it is good to use agent-based models. Now, another one is whenever you have some experiments that are impossible to perform in real world. And one of these, perhaps the most infamous example that is out there, is the experiment performed by psychologist Philip Zimbardo. As far as I understand, Philip Zimbardo wanted to understand the role of hierarchies and dominance relationship between individuals. And what he did is that he actually recruited individuals from the university, and then he put them to play a role. Some of them will be prisoners, and some of them will be guards. And then he let them play these roles. And things went out of control really, really fast. So the prisoners right away starting going out of the roles, really inflicting some kind of suffering into the prisoners. So this is a famous example of when experiments are unethical to perform sometimes. And then the ABM, then it's a good solution, because of course here there is no harm of individuals. And then you can think about many ways in which you can perform some kind of unethical experiments, because you need these kind of experiments to advance your theory. But then you will not be doing any harm into the real world population. Another one is when things become prohibitively expensive. So you can think about you want to implement new policies, and then doing or experimenting with these all new policies in a society, of course, it will be incredibly expensive. So then you can create an agent-based model of the society and then try these new policies and see what works best in the agent-based model. So finally, we can use the agent-based model just to get a better understanding of a system, to get a better theory. So the agent-based models actually are going to help us to integrate knowledge and processes into a whole. And once we do this, we may be able to observe what is happening in there. So we can have an understanding on what are the causal change, what are unintended effects, or what are the multi-level feedbacks that produce emergent macro patterns. So they will allow us to identify what scenarios emerge under what conditions and what mechanisms are actually leading to these conditions. So in that sense, agent-based models may serve us to refute or to reformulate hypotheses or theory, to identify loopholes in the theory, and to stimulate further development of theories. So overall, we gain a better understanding of the system and we can develop the theory further. So one and before going on to how to do ABMs, I want to touch into this, is what we call participatory modeling. And whenever you have a phenomena that spans across a lot of different sciences, such as these social phenomena, you have that most of these phenomena is not new. So it has been studied probably already for many years. So we as a modelers may think of ourselves, okay, we have this new tool, and we are now kind of make some breakthroughs with our new tools. But we shouldn't think like that, because there's a lot of people, a lot of researchers that have already been studying these phenomena for many years. And they understand these phenomena perhaps better than, much better, I would say, than most modelers. And these persons is what we call the subject matter experts. And these persons are actually vital. And only a fool will not make use of their expertise, because they can help us a lot in shaping the models, assumptions, and parameters. So participatory modeling means that we as a modeler need to have a group that guide us or contribute their expertise into how to build the model. So they are actively participating with their ideas and design concepts during the whole modeling process. And this is actually what we are aiming in this project. So how to build an agent-based model? And here I'm going to use the modeling cycle proposed by Grimm and Railsback in its book on how to do agent-based models. And the first point that they suggest is to formulate a question. So your model has to have some kind of a purpose. And for that, you need to know what your model is going to answer. You have to have a question. Then it comes the conceptual design. So in this case, you have to understand how all the components of your systems are connected. Once you get into that, then you can start looking at the structure. So what are your variables? What are the processes? How your variables are going to change when things are interacting. Then you go to the model implementation, to the analysis of the model. And then if everything goes well, then you can go and communicate the model. Otherwise, then you may reformulate once again the question and the whole cycle begins again. So formulate a question. What do I mean? And this, when I say formulate a question, there should be a specific question about the system, not just the system. And by this, I mean, you cannot say, okay, now I want to model the religion system. But what exactly do you want to model? What exactly is the purpose? What is your specific question about that system? And here I put, for instance, some questions that we had when we were doing some previous models about clubs in religious clubs. So for instance, some of these questions is when or how do people form healthy social or become isolated, right? Or what are the transition dynamics between going from one club or to no club? How do people affiliate or transition, right? So here, what I want to illustrate here with this is that here we have some specific questions. Why is this so important? Because whenever you have a specific question, this is going to help you to filter out non-essential aspects of your system. It's also going to help you to decompose the system into the relevant parts. How are these relevant parts connected? So, so you have to think very carefully about which part to focus on and which part to ignore. And this is going to be helped by your questions. So what questions does theory address? What parts are needed to answer those questions? And then is the representation analogous to the theory? It's really the question or what you're building similar to what the theory says. So once you have this, then you go to a conceptual design, which is probably one of the hardest things here. So because this is how you have to figure out how the whole things work, how the whole thing is connected. And here I have a conceptual design that I don't want you to focus in. So this is so you can have here, this is a conceptual design of labor markets. For instance, here you have different components at the individual level, and then you have to decipher how these things are connected at the individual level. So you have here enterprises. Also, these enterprises are composed by different things. And then you have to decide how all these things are connected. So this is, as you can see, it can become very complicated, but it's essential for your model. So here you will have the essential elements and processes, and you will put in all the hypotheses that you have to see how things are connected. Now, this can be based on theory, and that will be the best most of the time, but sometimes there is no theory. So then you may rely on your experience. Or sometimes you have to imagine yourself as being as individual within the system, right? So what do I do? What affects me? How I'm going to react on a specific situation. So whenever there is no theory, of course, you have to rely on assumptions. And sometimes it helps a lot to have some kind of verbal representation on how individuals will behave. So you may have, for instance, some rules of thumb. So you may trust kin over strangers, or you may ignore opinions that contradict your beliefs. So all this is going to help you to have a conceptual design of the model. So once you have this, then you come to how to structure all this. So again, here I put an example of a previous model that we've been designing, or we designed a couple of years back. And here is just basically an illustration on how this actually may look like. So for instance, you have to identify the essential variables of your individuals. And then here you will try to simplify it as much as possible. You have to put the small number of variables, the ones that are essential. And then you have to ask yourself, do I need to input age? Do I need to input sex? Is the social status important? So once you have that, which is going to tell you, okay, now how these things are going to work? What are the equations? How individuals are going to change the states? What is going to happen when they interact? And then you may come with parameters as well. And these parameters are going to tell you how much things change whenever interactions are happening. And finally, you have to come with some kind of a scale. So is your model spatial? If it is spatial, how is your model going to be divided? Is it going to be in neighborhoods, or is it going to be on some other, on the specific social networks, for instance? And then time. So how often these processes happen? Is it going to be every hour? Is it going to be every week, every year, etc., etc.? So once you have this, you come to implement them. And before implementing the model, something that I always find very is to write a description, a very detailed description of the model. Why do I do that? Because this ensures that not only me as a model, but also all the individuals collaborating in the model are extremely clear about what is going to happen in the model, how this is going to work. And this is going to save you a lot of time. Finally, then you come to a model architecture, which is some kind of an order of processes. And then you can make some flowcharts. So here I put a very simple flowchart of how a model may work, right? But you can have flowcharts for specific processes. For instance, you can have a flowchart on how an individual is going to make the decisions, right? So this is very helpful, and it's going to make your life easier whenever you are coding the model. Finally, you come to the fifth step, which is analyzing, testing, and revising the model. So one of the things here is that you should usually make a sensitivity analysis of the parameter space. So this is going to tell you how robust your model actually is. So if you're looking, for instance, for a specific scenario, then you may do a sensitivity analysis to see under what parameter range this scenario that you're looking for is actually happening. How robust is it really small space, or is it really big space in your life? Why are things happening? So it is not just saying, okay, now I have built this model, it's everything in there, and some very nice social phenomena is occurring. But why? What are the causing or underlying mechanisms causing this emergence? And importantly also, is this relevant to empirical data? Am I actually able to reproduce empirical observations? So this is some kind of validation of your model. So yeah, my model is actually able to reproduce the social phenomena that I was looking for, right? But also very important is that your model has to be able to be falsifiable, right? You have to be able to test it, right? It's not just enough saying, okay, my model reproduces the social phenomenon and that's it. Of course not, because there's many ways in which you can reproduce a social phenomenon. So then you have to have a way in which you can test actually whether your assumptions in the model are correct. And sometimes the best way to do that is to make predictions of the model. So the model may say, okay, under these specific conditions, the social phenomena may look like this, right? Or you may look, okay, my model is giving me some specific patterns of phenomena that have not been looked at in empirical data. So these are predictions that your model is making, and then you can use them to test it, to see whether your model actually comes close to what reality is, right? And then if your model is not reproducing or is not achieving what you want, then you have to rethink and design again. So maybe you have to revise your implementations and your assumptions. So some final remarks and conclusion about social modeling. So keep it simple, but not that simple. So you have to start very simple, and I always find this very useful, because when a model is simple, it's really easy to understand what is happening. Now, one of the things is that then you may need to add more complexity, right? The simplicity doesn't mean that your model is it's actually capturing the system. It just helps you to understand the system better. And once you understand the system better, then you can start adding some layers of complexity. Now, complexity creates new affordances because you have more opportunities to create some feedbacks, to create new emergence out of your system. Now, the other thing is that the more detailed you go, the more specific is your model to particular situations. So if you make a very detailed model, the kind of questions that you can ask are very limited, are very constrained, right? And the other thing is that systems can be modeled in different ways. So the way you model a system doesn't mean that it's the only way. And here I want to stress this, that all the compositions are valuable. So you can model a system in different ways, and you can learn from all those different ways about your system. So I want to conclude this section saying that of a complex system and are thus imperfect. You will never be able to capture all of the aspects in a complex system. So most of the models apply just to some of them, right? And understanding a complex system may require a family of models, right? It's not that a single model is going to capture the whole system. So you can make different models to reproduce different parts of your system. And finally, I want to say, well, if you want to produce a model, then don't override and don't concern so much about it. Just do the model, right? If you're diligent, and if your model fails, doesn't mean that it's bad. The model failures actually can tell you as much about the system as the model success. So just go ahead and. Finally, I want to. So with this, I finish. And now I'm gonna briefly talk about the Religion, Ideology, and Pro-Sociality project that, as you know, is led by Konrad, who is the principal investigator in Poland, and Leron, who is the co-PI in Norway. All right. So one of the goals of the RIG project, as Konrad already said, is to simulate the aspects societies using computational models. And here the main aim is to have a holistic understanding on how different theories may contribute to this secularizing phenomenon. So we're going to be looking at different theories such as magical ideology, error management, epistemic vigilance, existential security, and so on. And we're not only going to build models, but we're also going to use empirical studies. And the main goal of the model is to have a better understanding of secularizing societies and the cognitive and cultural mechanisms that underpin this phenomenon. So, as Konrad already mentioned, we're going to have 4 different projects. And then the main part of these projects are the model. But we're going to have models that focus here on the cognitive mechanisms, which are going to be basically system dynamic models. And these cognitive mechanisms in some models are going to drive the individual behavior. Some models that are going to be just from the individual behavior to the social complexity. So there's going to be a feedback or some interconnection between all these different levels of connections. So if you look on the focus, then you can see here that these models here are going to focus on the mechanisms, specifically on the cognitive mechanisms. Then we're also going to focus at the individual level and then at the group level. And then the main goal of the models, of course, is going to be to reproduce and describe the phenomena that we look at the empirics micro level, but also the phenomena that we look at the empirics micro level. So now I would like to touch a little bit on each of these 4 projects. But since Konrad already described some of them, I'm just going to go into what we're actually going to do for each of these projects. So we have the fuzzy fidelity model, and this fuzzy fidelity sub-project is going to be divided in 2 different stages. One of them is the empirical data analysis, in which we will attempt to reproduce the study by David Boas with new data of the European Value Survey. And this is going to be the basis for calibration and validation of the ABM model that we're going to develop. So the main aim of this model, of course, will be to reproduce the cellular. So this model is just going to be an agent-based model, and then we're going to try to reproduce the social complexity look at the group level. The second model is the prosocial equilibrium, as Konrad already mentioned. And here, we're going to, again, divide it in 2 different stages. One is in which we're going to make a survey in which we're going to look at the prosociality in religious and secular ideologies. We're going to look at the degree of fusion between secular ideologies, for instance, nationalism, and religious ideologies. We're also going to try to tease apart whether different ideologies actually lead to different prosociality. So, for instance, you may think that secular ideologies will lead to a prosociality which is universal. So you may be prosocial to all kinds of individuals, and religious ideology may be more parochial in the sense that you may just be prosocial towards individuals that share the same religious notion. Now, all this is going to be used to develop the model. So this causal architecture and the whole design of the model is going to be guided by the results of this survey and by some other theories like magical ideology theory. And the main aim of this model will be to study the conditions and mechanisms leading to high prosociality, while at the same time we maintain a high diversity of religious beliefs and ideologies. So that's for the prosocial equilibrium. And for the one will be the in which that Konrad already explained. And the reason we're going to use this is to explore how uncertainty and anxiety and other related variables that come out of the experiments may result in ritualized behaviors and its spread within specific groups of individuals. Now here we're gonna do two different types of models. So one is gonna be a system dynamic models, and these system dynamic models is gonna try to capture the cognitive mechanisms that lead to ritualized behavior, right? The empirical path gain, and we're gonna use also error management theory to come up with a system dynamic model. So you may think of these system dynamic models as like a little mind of the individual, and how individuals on the basis of this model may create ritualized behaviors. So once we achieve that, then we're gonna create an agent-based model. And then the agent's cognitive architecture of each of these agents is gonna be the system dynamic models that was developed in the previous stage. Okay, and the model then here is gonna try to look at the causes and consequences of increase or decrease magical and religious practices and beliefs in societies. Finally, we come to the epistemic vigilance, which is again divided into stages. One will be the empirical stage, and the other will be the modeling stage. And here again, the idea is to make experiments about epistemic vigilance, in which we're gonna try to pinpoint the factors and conditions triggering epistemic vigilance, being this epistemic vigilance about the source or being about the content. And then we're gonna develop models again. So now the models, again, one of them is gonna be a system dynamic models, which is gonna be based on the results of, and this is gonna be, again, some kind of cognitive architecture about the mechanisms on which triggered a specific type of epistemic vigilance. So once we get that, then we're gonna do an agent-based model, which again is gonna be each of the individual's behaviors and interactions will be based on the system dynamic models. And here the idea is to understand the conditions under which the epistemic vigilance systems actually interact with the cognitive mechanisms to increase or decrease magical religious beliefs and practices in a population. So this is a basic overview on how these projects are gonna be done. And then I just want to just finish right away with a little overview of the RIG project. And I believe the project promises to show how cognitive processes, behaviors, and interactions on the individual level lead to social change. And by taking into account a range of different existing theories regarding the role of religious beliefs and rituals, as well as secular ideologies, the project should be able to provide a framework to understand in a broad range of social and cognitive phenomena that will be valuable for many researchers. At the same time, the idea is also to show that how using computer models can be very valuable to understand social processes. So this project, we hope it can serve as a paradigmatic example of the use of a novel technology. And we hope that its influence upon the social sciences can be both widespread and enduring. And yeah, that will be it for my presentation, and then I'm ready to take questions.
All right. Thank you, Ivan. We have a number of questions. What I'll do is I'll read them out, and then I'll give you time to answer them. Okay?
Right. Should I stop sharing?
It's up to you, but potentially yes.
Okay.
All right, so the very first question is from Leon Cichanovsky, and the question is, can't ABMs be biased like mathematical models?
I think I will need a little bit more context there on what they mean by bias.
Okay, well, I mean, perhaps if Leon could rephrase that question, explain the question a little bit more. We'll come back to this question later.
I was going to say, while he's doing that, I can give an initial response guessing what he means there.
Mm-hmm.
I think ABMs are definitely biased. They're always biased. What I like about the methodology is that it forces you to be as clear as possible in defining the assumptions which makes your surfaces your biases, so that others can look at the code or the definitions or the conceptually clear definitions that Ivan was discussing there, and so it makes it more difficult to hide your biases, and it makes it easier to discover your biases. When we actually start engaging together as a team and you start trying to articulate your theory, suddenly you realize that you hadn't really thought about how you're defining every term and operationalizing it, and assumptions about whatever it might be, religion, immigration, secularization, attitudes. So yes, they're biased insofar as they're a human product, necessarily biased, but I think they provide a tool philosophically for surfacing those biases and guiding conversations about them.
All right, well, perhaps let's keep going, and if Leon wants to expand on his question, we'll come back to that later. Right. Second question. Actually, the second question is also from Leon. What is the difference between ABMs and structural equation models? I assume that means systems dynamics? No?
No, structural equations models. Yeah.
Oh, sorry. Yes. Okay. Great. Thank you. How do you assess the connections between concepts, elements at the conceptualization stage of your project? Or maybe you don't. Do you assess only the relationships between the agents?
Okay. Regarding the first question, well, structural equation models actually come from the analysis of data. So you actually have a specific set of data, and then you have different variables or factors in which you are trying to reduce the dimensions of what things are there. So, for instance, you may think about dimensions of religiosity and how different factors or variables may be forming one dimension, right? But this comes actually from the analysis of empirical data. So in the case of an agent-based model, you use empirical data to try to come up with the processes on how things are linked. So it is not exactly the same. So structural equation models actually can inform agent-based models. For instance, if you know, for instance, now from many different variables of religiosity that the dimensions are just 3 of them, right? Then you can try to incorporate the findings of those structural equation models into the ABN. So for instance, you can put an individual that has the representations of these dimensions from the structural equations models. And then you can even try to put into the model or into the ABM how the covariation between these variables happens that from the empirical data into the model. But it is not it's not the same. I'm not entirely sure if I'm answering your question there.
I thought that was a great answer, Ivan. If we have time, I can actually show an example from one of our previous models, how structural equation modeling is utilized within agent-based modeling? I think we have time, Conrad.
I think we do. I think we do.
Okay, let me see if I can share my screen here. Can everybody see that?
Yes.
Yes. Okay. So this is a model. Ross Gore, who's going to be with us this afternoon, was the lead author of Forecasting Changes in Religiosity and Existential Security in an Agent-Based Model. I won't go through the whole thing, but just to flip down here to show the. We use the ISSP data set. These are the factor analysis showed these latent factors in the data set related to religion. Then we did a structural equation model. Here we go, which showed that this was the best fit for the relationship, the basins into which the different factors flowed. So then this informed that structural equation model. Here we go, if you can see that. That's not very, let me see if I can make this bigger. There we go. So the structural equation model was placed within agents, initialized by sampling in earlier years in the ISSP. Without going into the details, that eventually that particular model was used to predict the shifts in those variables. This is one of my favorite figures here. The 22 different countries, if you can see them. How each of these variables went up and down. In the real world, the actual data is the triangle at the end. The circles are what the ABM predicted. And we were able to, we trained it using machine learning techniques on data from 1990 to 2000, then initialized it in 2000 to see how it could predict 2010. And it was up to 3 times more accurate than linear regression in predicting the following 10 years, how these variables would be altered. So that's an example of how an structural equation model can be utilized to capture the data, as Ivan said, and then inform an agent-based model.
Lovely, thank you.
So now going to the second question on,
yes.
on how do you assess the connections between concepts and elements. So this is basically coming from theory. And this is where the subject matter experts actually have a lot to say and a lot to help in designing and helping us to decipher how these connections are. We as a modelers, of course, can help on how we can do this into computer algorithms or how we can translate this into some kind of mathematical equations. But how the connections are there comes basically from the theory. And when there is no theory, then you have to come up with something, an assumption. I mean, if there is no theory and you think there should be a connection, you have to put something in the model. And that's why the models actually kind of oblige you to make these things very clear, because you cannot make this a bit ambiguous in the model. You really have to be clear of what you're putting in order for the model to work, how the individuals are going to interact. So if there is no theory, then you just have to assume things.
Okay.
Did you assess only the relationship between agents? No, not really. So it pretty much depends on what your aim is. So for instance, you may think of a very simple model on opinion dynamics in which you only have agents interacting, right? And then you only have relationships between the agents, perhaps. But if you want to make things more complicated, then you may think that in this society or in this model of opinion dynamics, you may have some other agents influencing the opinions. This could be the media, or this could be some institution, this could be the government. And then you have to tell how this relationship between the agents are happening. So now it's not only happening between individuals, but also among different types of agents. But it pretty much boils down to what do you want to achieve with your model, and what is the essential parts of your model, and what you want to, if it's necessary.
Okay. Next questions are from Andrew Atkinson. First of all, he thanks for a very clear talk. And then his question is the following. I'm glad you mentioned that models are analogies and imperfect. I wanted to ask if you intend to factor in something like Eric Kaufmann's claims that immigration of religious groups and the higher birth rates is something which is affecting secular decline in the destination country. Kaufmann's model predicts secular decline. Is this view wrong, or just another imperfect model that is only partially right, or just completely wrong? Incidentally, what are the predictions of the RIP project? Is religion on the decline or not? Ivan?
Well, given that I'm not really familiar with what Kaufmann's model is, I think this will be more suitable for you two guys, which are...
I could take a first stab, Konrad.
All right, go for
it. When we have David Vos able to contribute, that would be great. I know that he's written an article, I forget who your co-author was, David, but showing that when a new population that's from a context which there's high fertility, when they do move into a typically Western secular society, that after the second and especially the third generation, their fertility rates drop rapidly to around where the host population is. So this is a debate in the sociology of religion. I find David's arguments compelling. So, but one of the things that agent-based models can do is set up an artificial society in which we can test those kinds of hypotheses, change the fertility rates, alter the number and the flow of demographic projections of immigrants, and activate different mechanisms or parameters in that artificial society to see the extent to which they're going up and down, to test these kinds of hypotheses. So even if we're not referring to Kaufmann explicitly, that debate that he's engaging in will certainly be one of the issues we'll be discussing in the fuzzy fidelity model.
Yes. I've just noticed that David has written that he knows the model quite well. He knows Kaufmann's model quite well, and he'll be indeed quite happy to discuss it later during our fuzzy fidelity sessions, which will be, of course, tomorrow and on Wednesday. All right. Perhaps if I'll just hit on that last few questions that Andrew asks. What are the predictions of the RIP project? Is religion on the decline or not? Well, in a sense, we don't have the predictions yet. We're going to develop the models, and only once we have the models will we be able to make predictions. I think one very important element in that set of questions will be what kind of effect should we expect the climate catastrophe, which we're heading towards without much in the way of it, what effect that's going to have on secularization. Now, without the benefit of the models that we are going to develop, my own personal guess would be that it's probably going to stop secularization, in fact, lead to an increase in religiosity. But that is for the models to be able to tell us a bit more about. And, you know, as Ivan was saying earlier, what I've just said is very vague. It's all just a bunch of words without concrete hard predictions, which is, of course, what the models will allow us to make. Yeah? Okay. So we're back to Leon Cichanowski. And he's saying, yes, I'd love to see an ABM model. Well, there will be a whole bunch of ABM models that we'll be discussing over this week, I think. So that seems to be the answer for that one, right? Or Ivan, do you have one that you happen to have one ready in your pocket right now?
Not in my pocket right now, but I think we're gonna have one on the fuzzy fidelity session tomorrow, tomorrow afternoon for sure.
Sorry, I just noticed another thing that Loan wrote, but in the end, in the ABM, you try to model the main concepts of your theory. Is that true? Is it a fair description?
I think so, and all the little concepts that are necessary to implement the model. Because you may have main concepts of your theory, but whenever you're building a model, then you realize that you need some other things, some more details to really make the connections between all the processes. So all those main concepts for sure will be there, but sometimes you have to dig a bit more or make assumptions on how things would be connected.
Okay, great. All right, okay, Alicia is asking what I think is one of the key questions in the process of developing these models, which is how large has to be the data set compared to the number of parameters in both types of models?
I'm not entirely sure I follow, but I guess, so the data sets that we use in the models are basically for calibrating certain processes. So you may have different types of data sets, for instance, for the cognitive mechanisms. That could be one kind of data set. And then the model will attempt to reproduce that specific data set. But not only that, so then you may have data sets that describe things at the societal level. So then you have a different type of data set that is going to choose either to inform the model, or the model will have to reproduce that specific type of data sets. Now, compared to the number of parameters, well, models can become very complicated, and one of the things is you have to try to keep the number of parameters as low as possible. Because the more parameters you have, of course, your parameters space becomes incredibly big and may be impossible to study the whole model. Sometimes you may have parameters, and then you can ask, for instance, the subject matter experts to tell you how to restrict even more that parameters space. So, for instance, if an individual lives from 0 to 100 years, then the subject matter experts may tell you, okay, the crucial part of the lifespan of individual is during this age, and then it makes sense just to have some interactions during this age, or during this other age, interactions may have a lower impact, etc., etc. So in that sense, you may restrict more your number of parameters, or the values of your parameters will make your life easier whenever you want to explore the whole model.
I think what's also important here is the strategy that you talked about beforehand, which is that you start off with as simple a model as you can. You see that works, and then you add the other additional parameters to, as you said, add the range of possibilities of what you can test, what you can try out, where every step is first of all justified on the basis of existing data, existing theories, and then of course gets tested, and you find out whether the outcome of that is at all sensible.
Yeah, but I will also I would like to stress also what is the purpose of your question. So sometimes you want to add complexity because we live in a complex world, but sometimes your question you don't really need so much complexity to answer that question or the specific question you have. For instance, you may want to know, you may want to add different attributes related to sex or to age. But for instance, if your model is not trying to answer a question related to the sex of individuals, right? Is there a difference, for instance, in the gender, on how religious beliefs are spread on within the society, etc., etc. If that is not your question, I don't really see the relevance, for instance, of adding gender into the individual. So these things, that's why I'm saying that the question always helps you to simplify and try to take out those complexity that may not be necessary in the model. And that will help you to reduce the number of parameters.
I think the way you said it earlier, Ivan, during your presentation was really nice. We want it to be as simple as possible, but not too simple. Yeah, so simplicity is good, and so that's the issue of data is really fits there exactly. You want the best data that you can get for the specific kind of question that you're answering.
Yeah. Mm-hmm. Thank you, Laurent. I think that actually hits exactly the question that Alicia just added, which is, what is the optimal number of parameters?
It depends on the research question. Some of our previous models, for example, when we were modeling the shift from hunter-gatherers to sedentary agriculture societies in the Neolithic, we had 17 parameters or something like that, and 28 variables. But some of our other models only have maybe 3 or 4 parameters. So it really depends on the research question and the kind of data that you have and the sort of theory that's guiding the conversation.
Yeah.
I thought I can share another screen, Conrad, if I can.
Go for it.
Yeah,
we have time.
Yeah, here's another way of thinking about how models work and how data fits in here. If you can see that, is that large enough?
Yes, perfect.
Okay, so there are more than this types of models or uses of models, but you can think of prediction, explanation, retrodiction, and a kind of emergence explanation. The X refers to what we know, some data we have in the real world. The circle, what we want to know, what we hope the model will teach us, right? So if you want to have a predictive model like the one that I was showing earlier, you have already you have data for the input, the ISSP data sets, and you know what the mechanisms are, or you postulate the mechanisms related to education, homophily, interactions, existential security, and so forth. And then the output, which you don't know, is supposed to say this is where those variables will look in different countries under various conditions 10 years from now or whenever it might be. But it could be that you're not interested in predicting, you're interested in explaining. In that case, you might know what your input is, and you already know what the output is. You're not trying to predict, you know what's happened. You're trying to explain something that happened in the past. So then you're trying to figure out what the mechanisms are. So here, in a way, you only need data to calibrate your, or to give you your input and to validate your output. And then you let the computer discover and explore different kinds of mechanisms that might get you from the input to the output. Retrodiction, we've only done a couple of these kind of models, but here you know pretty much, or you postulate your explanations and you know what happened historically, but you have no idea what got things started. You're not sure what happened in the past that led to the specific outcome. So here you need data about the.
If I can come in on that, one of the things that we want to try and do with the fuzzy fidelity model, which is, I think, a case of retrodiction, is to try and trace things back in the various societies that we have data for, to see when the secularization processes began in those societies, and then to be able to look at the historical situations in those societies to see what the similarities between those societies were at that point in time.
Precisely, especially the fuzzy fidelity model.
Exactly.
Yeah. Okay.
Okay. Couple of additional points. Andrew's saying the climate catastrophe is indeed Kaufman's concern. So that. We'll be coming back to this during the fuzzy fidelity discussion. And Roger Norman just really liked your presentation, Ivan. Well done. So But can we have more questions? Because we have lots of time, and we are very keen to continue the discussion. Because people are giving questions by typing them in, it's difficult to be able to judge to what degree they're simply sitting there and waiting for somebody else, and to what degree they're madly typing away at this point in time.
While we're waiting,
yes.
Not that we need to go to noon necessarily, but just to reflect on an issue that came up earlier. I think it was Leon was discussing with Ivan. So one of the big questions in the cognitive science of religion is the relationship between cognitive and psychological mechanisms, evolved mechanisms on the one hand, and sort of cultural, sociological, macro level factors, and how that forms and evokes and alters those mechanisms, leading to all kinds of different social phenomena. So some people in that field see humans as or most humans at least, as naturally defaulting to religion. I think probably almost everybody believes that that's at least maturationally natural for the bulk of the population. But the question is, when climate change starts to happen, or if there are contagion threats, for example, a pandemic, or lots of immigrants suddenly move in, or there's lots of predators. These are the four kinds of threats that humans naturally evolved to react to. And two of our models have these in the environment, so you can play with how those threats impact people. The question then becomes, as those threats become stronger, which threats and under what combination of threats will people go back to the tendency to believe in supernatural agents and engage in causally opaque rituals that aren't effective? So some believe that when there are these threats, many people would just become religious again. Others believe that the formation of education at a certain point, they kind of tip over, and it's like, no matter how bad things get, I'm not going to believe in witches or invisible spirits anymore. So the question is, how much of the population will shift back, under what number of threats, in what kinds of social networks? So computer models can force you to be really clear on what your research question is, what the assumptions are within that debate, and then give you an artificial society where you can tweak the number of predators or pandemics or immigrants in the model, and you can alter how religious the population starts with, what percentage of different kinds of groups are more or less religious, again operationalizing religion in specific ways, how much toleration people have for those threats, how quickly they tip over and become religious again. So you can test and explore conceptually and empirically those types of hypotheses.
Cool. I just, sorry. We have another question from Leon, and Andrew's saying he's about to ask another question. So first of all, question from Leon. Sorry for maybe coming back again to the basics, but I still don't really grasp the idea of ABM. Ivan said that it's not only measuring the relationships between the agents in a network, but it's also modeling the main concepts, or let's say laws of behavior of whole groups. What are, or what can be, the studied units of ABMs?
What can be the studied units of ABM? Well, basically in our models, the basic unit of analysis, actually the person will be the behavior. In this case, for instance, in the case of the models concerning the error management theory or the epistemic vigilance, we're going to go a bit deeper there, because we're going to try to pinpoint the cognitive mechanisms that are actually giving rise to this specific phenomena. So in that case, we will first come up with a model that is going to tell how these cognitive components interact between each other, and then how they give rise to a specific individual behavior, right? And this is going to be based on the experiments that we're going to have. So the thing here is that these system dynamic models is going to be specific for each individual. So each individual may have different behaviors, even though they have exactly the same specific cognitive components. Now, from these components or these simple units of cognitive mechanisms, some behavior is going to emerge. And this behavior has to vary between the individuals. So the system dynamic models has to be flexible in that sense, or may have different initial conditions for each individual given different behavior. Now we know how the behavior of an individual may work, and then you put these system dynamic models in an agent. Now, this agent now is going to be in a group or in a society, then is going to be interacting among each other. And now you go to how individuals may interact. What are the rules going to be governing this kind of behavior? So what are the units studied in the ABM are all the units at different levels. So we can really go from the really simple cognitive mechanisms that then are going to giving rise to the behavior of the individuals. So then you study the individual itself, and then these individuals are going to interact in a different level, at the meso level. So now you're going to be studying the interactions among these individuals. And then if these individuals have some other external factors that are affecting the behavior, that's another unit. So the thing with the individual-based model is that you're actually making like a smaller model for each of the components of the whole thing. So you're actually studying each of these units of the whole system. So you're actually studying all of it. I'm not sure if.
Yeah, if I can just add, so you have, there's a heterogeneity of agents. So imagine it's not neurons connecting with each other only in networks. It's every agent is different. They may be more or less religious, male or female, different ages, whatever variables you need, and they're interacting under different kinds of conditions. So that's one of the main differences. Another is most artificial neural network approaches, you end up with a black box. You're not really sure exactly what it is that happened, what the mechanisms that get you from one place to the other. That can happen in agent-based models, but typically you get more insight into the actual mechanisms and interactions. Yes. Justin Lane and I just published last month an article on that describes the difference between these kinds of models. So I don't think I've sent it to you yet, Conrad. I could send that to you and you could make it available to your team.
Wonderful.
Perhaps I can give a little example to make things clear now, because I see now that maybe there is a confusion there with the main concepts. So, for instance, when you look at secularizing societies, some of the theories say that it's socializing, which is one of the main drivers of secularization, right? So you go to church and then you have these practices, you have mass, and that kind of reinforces the beliefs and practices of individuals. That would be one component. So this is one of the concepts there. So in the model, for instance, you may have to produce this process. So you may have an individual that has not only the beliefs, but also the motivation to go and have practices, right? So then you will have to come up with a process in which you have, okay, how individuals are going to come up together, how are they going to decide whether they go to church, what is going to happen when they go to church, how this belief is going to be reinforced, how this motivation to practice is going to be reinforced, or how it's going to decrease if this process is not happening. So that's one concept. Now, the other are that there are some external factors that could also modify the decline of religious beliefs. So for instance, you have existential security. That existential security may decrease the anxiety of the individuals, right? And then this anxiety of the individuals, or make them secure about their existence, will decrease their motivation to go to practices. So then there is this other context of this other theory actually coming into the model. So how are you going to measure this, or how you're going to model it, right? So you may have some kind of variable deciding how secure individuals are in a society, or you may decompose it. You may decompose it into different institutions. I don't know, an institution providing the health of the individuals, an institution providing the education, or so on. What are the components of existential security? So then you have to ask yourself, what is that? So what is existential security actually? And that's when you come and ask to the experts. So tell me how I'm going to decompose existential security. What are the main components, right? And how these components, being this health, being this having a job, being this having an education, how these components now are going to affect the anxiety of the individual. So is it that an individual values more education? Is it that an individual values more job? Is it that an individual values more, I don't know, their access to health? And that's when those concepts start to be teasing apart. And that's when the expertise of these subject matter experts comes in. Because I may know how these interactions or these processes may affect the variables of anxiety of the individual. How these are connected and how much they are going to affect the anxiety of the individuals, that I don't really know exactly, right? And that's when the expert comes in and helps us to design the model. So yeah, so all these concepts come together into the model. They are interrelated, but at some point you have to start decomposing them. Or maybe you don't want to decompose it. You want to keep it simple. So you just say, well, there is a simple variable that is called existential security, and you don't want to decompose it in different things. And then you just leave it like that in the model. And this, you just vary it. It can be just a simple parameter going from 0 to 1, and then 1 being, okay, now everybody's very secure, and then decreases the anxiety of all the individuals, etc., etc. So yeah, so I hope that makes it clearer.
Okay, well, Leon has a few more remarks to make, but I thought we'd go to Alicia's next question for now, and we'll come back to Leon in a second. Alicia's question is, how do you estimate errors in the simulation model? Is it somehow similar to the solutions used in linear regression?
So errors in the simulation, so it can be, it pretty much depends on how the individual's agents are making a decision. So if you want to go to a linear regression, yeah, so you can make a linear regression on how the individual is going to make a decision based on two different variables, right? But you always have, in a linear regression, you have always some uncertainty level, what you call error, right? So let's say that you know with a 70% certainty that the individual is going to do decision A instead of decision B. So what you usually do in an ABM to represent this error is you just draw a random number between 0 and 1. And then if the random number falls within a specific range, then you go for one decision. And if it falls within another specific range, you go to another decision. So that's how would you implement errors. Or if it's completely uncertain, then you just say, okay, depending on what the random number goes in, you take just either a random decision or you take a specific one. So, but basically is comparing the decisions to random numbers. So that's how you kind of do errors in the model.
Mm-hmm. Okay. So a few remarks from Leon. He says he's asking about the neural networks because he has a lot of experience in neural networks, but not with ABMs. Ivan, you want to add anything with regards to neural networks on top of what Leon already said?
Not really. To be honest, I'm not so familiar with neural networks. I only know about machine learning and neural networks. And once I tried to build some predictive models with it, I know that the things with machine learning is that they are basically a black box, right? So the way neural networks works is, I believe, you have different layers of networks, of neural networks. And then each of these nodes are connected, and then so the thing is that they are going to make a perfect work on prediction, right? But the problem is that how these nodes are connected and what does these nodes represent and how they are actually making the prediction, it's basically kind of a black box. So machine learning is really good at making predictions, but it's very bad at trying to understand how is these predictions, or understanding why the mechanisms behind of those predictions. So that's as much as I can say, I hope.
Okay. Are the modeled relationships between persons something like assessing the weights between neurons and neural networks? So I think that's already been answered. And one more remark from Leon. So through the behavior of individuals, we try to predict their personal characteristics. And later, if we want that, we can also predict the rules of behavior of similar individuals. I think that goes back to something that you, Leron, were saying earlier on about the different ways in which these models can be used, right? Oh, we can't hear you for the moment. Your mic is off.
There, is that better?
Yes.
Yeah, I would say it this way. You set the variables or the characteristics of the individuals, that you initialize them with certain variables based on data or subject matter expertise, and then this is correct. You run it to predict how those variables change under different behaviors and interaction rules. So then, similar in the sense that if you have a model in which there are new individuals being born, or you're studying a different population based on the previously calibrated model, then other individuals who have similar characteristics, you can predict how they would interact or change their variables based on different conditions. So I'm just trying to fill out what you said there, but that's correct.
Okay, and Andrew's next question. With regards to the climate threat, it appears to me that religious populations growing larger, effectively contributing to overpopulation, means that there are many more individuals around who share end times beliefs, such that worldly doom is offset by faith in divine salvation. For example, carry on burning the fossil fuels, even though we know it's ruining the environment. It doesn't matter because the Messiah returns soon. If that's the case, one kind of threat could effectively wipe out such populations, and fitness doesn't equal number of offspring. So I see a model that starts off with religion being adaptive, but then turns ultimately maladaptive. At what point does the model shift from one view to the other?
Yeah, exactly. This is the kind of thing that we would love to do modeling on. At what point can you have particular variables being adaptive and then shifting over to being maladaptive? So even though that's not a formal research question in the RIP project, I think, or hopefully, we'll be able to include that kind of hypothesis and test and explore under what conditions would such populations likely be wiped out? I mean, because one can imagine situations where they would continue to dominate and even suppress non-religious populations, and then the entire species would go extinct, right? And it's unfortunately easy to imagine that kind of scenario. So once we have the model set up, it becomes a kind of tool for guiding conversations about what's most likely to happen if these kinds of variables in the populations are this strong under different kinds of conditions, these can lead to all kinds of ethically and politically touchy discussions. But at least now we would have a sort of, at least somewhat empirically calibrated model that's super clear, that can guide those conversations.
Yes. Ivan, you want to add to that?
Yeah, if I may add in there, I think here we're basically talking about two different types of models. So the models that we're trying to come up with are mostly mechanistic and trying to understand the phenomena in a shorter time span, which you may call historical. The types of models that here he's referring to will be mostly on evolutionary timescales. So we will have to have an evolutionary model. And then we will have to create things such as fitnesses and what makes society survive better than the others. You may have a model in which you have resources, how resources are exploited, what happens when the resources run out, does the fitness decreases, when does the society collapse. So I think this will actually require a different kind of model, because when you're talking about adaptive and maladaptive things, then you may have to have a fitness equation going into it. And our models are mostly not related to fitness, because in our models, there's no, you can impose codes, but we are not actually doing that, because our aim is to understand the mechanisms leading to decrease or increase of religious beliefs in a population. And in this case, it's mostly when something can be adaptive or maladaptive. So the type of questions that you're asking here will be a bit different, and it may require a bit of a different model.
Okay, so there's thank you from Leon. Sorry, from Leon. Thank you from Alicia, from Andrew. And I think that's pretty much
if you open the chat, I think there is a comment by David there.
About Kaufman, yeah. I know David has a really nice article on this. I can track it down, or maybe he can post the co-author.
So I'll just read David's comment from the chat. I'll have to comment here because I'm using a desktop that doesn't have a webcam or mic. Regarding Kaufman, I agree that we need to take immigration into account. It obviously changes the character of the religious landscape and can affect the distribution of religiosity. I'm dubious, though, about the claim that, for example, the growth of the Muslim population in Europe is likely to result in an appreciable slowing in secularization. Okay, that does sound like very interesting, and because I'm not familiar with that article, I myself would be very interested.
I tracked it down. It's VOS 2012. It's called Islam Moves West.
Lovely.
And he spells out the argument that he's posted there really clearly.
Lovely. Great. All right. Well, there are no other questions right now. And I think this has been quite an intense morning. So I'm all for taking a break now. The next session is supposed to start at 1:30 Central European Time. And I believe that it begins with an introduction to the pro-sociality model by Euleron. Yes?
That's right. Yes.
And then, of course, we'll move on to actually having a group discussion where we try to start conceptualizing that model. All right, everyone. Thank you very much for your help and your questions and your presentation, Ivan. And I will see everyone at 1:30 in the afternoon. Thank you.
Thanks, Konrad.
Thanks, Konrad.